Welcome to the webinar. This is Sydney speaking. I will be giving the webinar. Today's webinar, as you've read, is tips and tricks on 2.5D, on 2.5D milling. Now, actually, the reason why I'm giving this webinar is because I've gone through customers and I've noticed there's certain functions in 2.5D milling in certain areas where they do not necessarily use them as much as they should, or as I feel they should, and they can actually be a lot helpful, very helpful when they use this kind of functions. So I decided to do this webinar on this issue, and I'm going to go through several of the different options that we have in 2.5D and show how we can use them to their best to the best of their possibilities. Again, if you have any questions, just feel free to write them down. All you have to do is click on raise hand, and in the area where it says questions, just write down your question. And don't forget, when you finish writing down your question, click on the send button as shown over here. Okay, so let's get started. And you'll have to excuse me, I'm a little hoarse. I have a little bit of a cold, so my throat is a little scratchy, so you'll have to excuse me every now and then. Okay. What you see on on the screen right now is a simple 2.5D part, but this part, everything that you see over here, I'm able to do this in all the operations that we have inside of what we call toolbox. Now, what exactly is a toolbox? A toolbox is actually made to make your programming time faster. It takes a lot of the guesswork away from you and makes it a lot easier to do certain operations. And I'll go through some of them as we see on this part. And the first one I'd like to do is actually this long slot here. If I take a look from the top, we have one slot going along on the very top of the part. It's relatively narrow, okay? And both ends are open. So if I were to go into my 2.5D toolbox cycles, we have the option over here, what is called simple slot. Now, what simple slot actually does is I just want to go in one end, come back the other end, okay? And when it goes out the other end, I just want it to go across to the other side. It doesn't even have to go up. I don't want it to even go up to its clearance level, just to go out, across, and back. That's all I wanted to do. Nothing more than that. So when I choose my geometry, I'll choose this edge over here and accept that. And it doesn't make a difference as far as the directions goes. It can both be in the same directions, both be in the opposite directions. That is really irrelevant as far as the operation goes. I'll just set it okay. The tool, I'll use in this particular case a tool that is a 10 millimeter end mill. And my levels will be, my upper level is over here, and my lower level is down here. My depth is down up until there. Total of 5 millimeters. Now let's go to a technology field. If you note, as opposed to profile, there's very little that I really have to do over here. Okay, you'll note that even after technology, there's no link. No link is necessary. What we have here is step down. If I want to have a specific amount of step downs going down the part. If I want to leave a wall offset, I can leave a wall offset. And I'll even do that. I'll leave a 0.2 millimeter wall offset. And if I want to do a finish on the floor, on the wall, we have wall finish as well. We have one more thing, is the extension. How much do I want to go past the part itself? I'm just going to write in here 60% of the tool diameter. That's all I have to do. That's it. We're done. Save and calculate. Simulate. And you can see the tool will go down, outside of the part, go across. Now look at what happens over here. It doesn't go up to get to the next wall. It goes directly across to the other side. 2 separate chains. Goes directly across to the other side and comes back. Now it's going to do its finish. across. Sorry, I did it a little bit too quick. Our first step, our now second finish step. That's all we had to do. And it's a very simple operation, but it makes the programming time of this slot easy. I did not have to make 2 chains in opposite directions and have it go up in this end and come back in the other side. No lead in, no lead out necessary in this particular case. That's all I had to do. All right, that's one simple case. Now, let's go to another situation over here. If we take a look inside this slot over here, we have 5 narrow slots over here. And the way I'd like to do this is the width of this slot is exactly 6 millimeters. And what I'd like to do, I'd just like to take a 6 millimeter end mill and go back and forth into the slot, going down all the time, just clearing out the material. I don't want it to move to the side or anything like that. Just go back and forth on the side. That's all is necessary. I have no major tolerance over here that I have to follow, so I have no problem doing that. So I'll start another recognition a 2.5D operation of toolbox, and this time I'll use the option of closed slot. Choose my geometry, and this time when I choose my geometry, instead of going to each chain, I'll just use the option of multi-chains. And if I go into multi-chains, we have an option of faces. The reason why I like using this option of faces over here is because, okay, I can say I don't want the external loops, I only want the internal loops. So let me get rid of external loops. Now when I touch the surface, it picks up only the internal loops, as shown over here. Okay, picked out that geometry, no problem at all. The tool, as I said, I'm going to use a 6 millimeter end mill. Let me actually change the color of the tool. I'll do it at a different point. Select that. Levels, upper level, we have our depth. Technology. Note, there's really nothing in my technology. The only thing I have in my technology is my step down. I'm going to leave it at every 5 millimeters. You know what? I'll make it every 3 millimeters. And what's actually going to happen is as it goes into the part, it's going to go down 3. As it's going to the cross, then go down another 3. In other words, it's going to work in a zigzag formation. Let's draw the simulation on the part. And I just want to change the color of the tool. So we'll go into this tool over here, change it to that color. And we'll run a simulation. I'll do it one step at a time. You can see as the tool goes down, it goes across. Sorry, my mistake. My levels were not correct. My my upper level was here. And my depth is up until the very bottom of the part. My mistake. I'm only human. Okay. You know, I'll even give it a little bit of a delta, -1 millimeter. Save and calculate and simulate. Run my simulation. And as you see now, the tool will go down. There we go. Goes into the part. And as you see, as it's going into the part itself, it's also going down. It's going back and forth until it finishes the part, until the very end. When it finishes it, it'll come up. And as you see, it went through the whole thing. Go across to the other side. And at the very bottom, by the way, when it finishes the very bottom, it actually does one pass that's going very straight at the very bottom to clean up whatever's left over, as it did right now. Same thing over here, going back and forth. Very, very useful operations. Okay, now I've had actually a customer that has very small slots exactly like this. Very small slots. What I mean by very small is that their width is a total of 2 millimeters and their length over here is a total of 15 millimeters, but he has around 500 on one plate. And what this actually does, it allows you not to have to go ahead and choose a line in the middle to go down the middle, but it automatically figures out exactly where the middle is. So what he used to have to do was he used to have to draw a line in the middle of each one of those, and that was, of course, you know, with that amount of slots was really painstaking. But with this way, all he had to do was pick a surface, he got his slots, and he just was able to do his slots with no extra hassle. Okay, now I like to work now on this slot over here, which is very similar to this, except this is much wider. And the way I like to work on this is to actually go down and then clear off towards the sides. So let's just do a quick save and copy. Choose a new option called Spiral Close Wide Slot, as shown over here. Additional zigzag slot. Okay, where it has a zigzag and then it does additional moves on the side. Our geometry is going to be this edge over here, around, and this edge over here as well. The tool that I'm going to use my 10 millimeter end mill, and the levels, my upper level will be from this surface over here, and my depth will be up until this point over here, till the very bottom. Okay, my technology, we have a few more fields now here instead. First, we have our step down. Our step down is how much it's going to step down each time. Let's leave it at 3 millimeters. And then we have our ramping width. What the ramping width is, you note that we have a zigzag over here. The length of the zigzag, that's the ramping width. And we have the angle. What's the actual angle that we want to have as it ramps into the part? I'll leave it at 5 degrees. You know what? Let me make it 3 so we can see it a lot more. And then at the very bottom, how much of a step over do we want each time? Let me just have it at 2 millimeters. I can have it with a wall offset and floor offset, do the floor and wall offset at the end, or leave it just the way it is. Let's just leave it the way it is right now, and let's see what happens. As we start the simulation, you'll see the tool goes down, does a zigzag up until its first step down, then does another zigzag to its second step down, and does that all the way, goes until it gets to the very bottom. When it gets to the bottom, it'll do a finish on the floor itself, on the wall itself. Notice when it does the finish on the wall, it does from the middle of the slot itself, clearing out towards the edge, stepping out 2 millimeters each time until the very, very end, as shown over here. Very simple operation. Again, these are canned operations that tries to make your life a lot easier as you're programming with the program. Excuse me. Next, on the same part, we have these areas around here. This is very typical of having O-rings that you have to put on the parts itself. And you'll have slots around pockets like this, whatever type of slot you may have, where you need to put an O-ring in. And the way I'd like you to work on the O-ring is very simple. I like to go down first in the middle and then clear off the side walls. And that's exactly what O-ring does. If I were to start my new operation of toolbox cycles, we'll choose the option of O-ring as shown over here. My geometry will be this edge first, close it, this edge over here, this one here, and this one here. Okay, note that the O-rings, the walls are equally spaced between each other. The tool, I'll be using a smaller end mill, a 3 millimeter end mill. The width of those slots are 4 millimeters. So I'm using a 3 millimeter end mill. And my levels, we have our upper level at 0 and my depth at the floor of that O-ring over there. Go down to my technology, we have the following. We have our step down, how much do I want to step down each time when we're doing the rough operation. Now, in the middle, I'm going to have it step down every millimeter. Now, when it goes down in the middle, it's actually going to do a spiral cut in the middle. This way, as it goes around, it's also going down. Now, when it gets to the walls, I'm going to go directly to our finish. I want it to finish the walls as well. Let's see exactly what happens. Run my simulation. You see the tool goes down, and as it's going around, it's also going down into the part, further down, as shown over here. Now, when it gets to the bottom, you see now it's going off towards the outside wall. And on the other side, now goes to the other side. And it does the same on this side as well. Now let's take a look at this from our top view. But this time we'll take a look at it without the solid verification so that we can actually see the tool pass inside over here. Note what happens. You'll see that as it goes down, it gets down to the middle. And then when it gets to the bottom, when it goes off towards the wall, it actually does it in an arc formation. It goes in radius in and radius out, and then works over to the other side as well. And this is all done very simply with one operation of O-ring. Now, one more operation I'd like to show you on the part itself is dealing with open corners such as this one over here. Okay? We have an operation inside toolbox cycles called simple corners. Now, what this does actually is as follows. All I have to do to clear off this corner is just pick these edges over here. It'll automatically figure out exactly where the corner comes out to, and it will clean exactly only in the areas where it has to work. Normally, if you would do this in a normal profile operation, the problem is you do this with clear offset. The clear offset at this point over here, we're working in the air without cutting any material at all. It'll be just cutting a small amount of material over here, but in this area, it'll be wasting time. What this does is it finds out exactly where it has to work. And let's see exactly how this works. If I were to touch this edge over here, pick this edge over here, that's my geometry over there. You know what? Since I'm doing it already, let me do all of them over here as well. I'll do this one, and this one. Sorry, my mistake. This one, and this one. I'll do 1, 2, 3. And 1, 2, and 3. Excellent. Next, I'll have my tool. My tool will be my 10 millimeter end mill. And I have my levels. My upper level will be over here. My depth will be up until this step over here. And in my technology, we have our step down. Let's have it go down every 5 millimeters. And we have our step over. How much I wanted to step over each time. We can have it also with wall offset, extensions. We have passes. We have working in one direction or zigzag. Let's take a look exactly how this is working right now. I'll run my simulation. Let me actually do it with the solid verify. I'll do it again. You see it starts from the corner. And it does each corner. And note from the top view what happens. It's working only in the areas where it has to work. It does not work out in these areas because in a profile operation, if you do a clear offset, it takes the entire wall and just pushes it out. So you'll end up working these areas with this size of a toolpath out here as well. This is actually saving you time without having, it just cuts only where it has to work. Okay, let's start now going to our next part that I wanted to show you. I wanted to show you some of the options that we have in Face. We have an operation in Face called Face Operation. And what I'd like to do here is first do the very top of the part. Okay, the very top, obviously, the way I'm going to do it is just take a 2.5 operation face, choose my geometry. In this particular case, I'll just choose my target over here. My tool, which is wider than this part, a 125 millimeter face mill. My levels, my upper level, I'll have it at 1 millimeter for my excess material, and my face depth up until this surface over here. Now in my technology, instead of hatch, since my tool can cover the entire part in one, it's wider than the entire part, I can do this with one pass, so it'll automatically make a pass down the middle. I don't have to do anything else. Save and calculate, simulate, and as we see the tool go down, across, up, and that's it, we're finished. Now, all fine and dandy, it's simple face operation, but let's see what happens further on. First of all, I like to clear out this area. So obviously that area, I'm going to use a pocket operation. I'll do that very quickly. Very simple pocket operation. I'll just use multi-chains. Click on that surface. We're all set. Use my tool. My tool in this particular case will be a 12 millimeter end mill. No problem. My levels all set. Pocket depth up until the surface over here. I'm just going to do a quick save and calculate so you can see what happened. And it cleared out that surface. But note what else happened. I still have to clear out the top of these stubs as shown over here. Okay, so the way I'm going to do it is I'm actually going to use face operations to clear off those stubs. This is what I'll do. I use 2.5D face. And when I go to choosing my geometry, instead of choosing models, I'm going to use the option of faces. When I choose faces, I'll just click on this surface, and this surface. 3 different surfaces. Now, when I accept that, what I will first do will actually try to connect them and make one big surface out of them. But this is not what I want. What I can do is separate them. So now when I do separate, you notice I have 3 different areas where I can work. Now what I'm going to do is since the width of this area is 10 millimeters, I'm going to use a 12 millimeter end mill. That one over there. And my levels, we have my upper level is going to be over here. And my depth is going to be, my face depth is going to be over here. And in this particular case, my technology, I can use one pass. Here I'm using one pass inside of this area over here without working on the entire model itself. Save and calculate and simulate. As you see the tool go down, go across the part, go up to its clearance level, go over to the next area over here, back up. But you know what? I'm saying to myself, why even go up to the clearance level? Well, you know what? You're right. I'll go into my link and say between each chain, just go up to my safety distance. Now let's see what happens. I'll do my first pass. No, it only goes up to its safety distance this time. and then goes back down. So in this particular case, going back also, I only did these surfaces over here, one pass, and I also showed, excuse me, I also showed how I don't have to go all the way up and keep it down from the clearance level. Instead, by chains, I made it through safety distance instead. Okay. Next, I'd like to show you one of the options that we have in our profile operation. So I'll take a part that I use for profile. Okay, now what I'd like to do in profile, I'm not going to mill out the whole part, don't worry about that. What I'd like to do is actually work on these two steps over here. Now when I work on these two steps, I on purpose will be using a smaller end mill. I'm using the distance over here, if I remember correctly, is, I believe, 20 millimeters. We have from this surface over here to this surface over here, we have 20 millimeters. Okay, so I'm going to use actually a smaller end mill. And I'll start a new operation of face mill. What I've actually done is I've milled out already up until that area over itself. I'm going to start a new operation of profile. Sorry, profile I said. My geometry, I already have it. I believe it's this one. Sorry, no, this one over here. There we go. Show. We have one over there and one over there. That's my geometry. The tool I'm going to be using, excuse me, is a 6 millimeter end mill. And I'm doing this on purpose. Okay, I know I can use a larger tool, but I just want to show you exactly how I end up how this works as far as cleaning off the steps. Levels, my upper level is over here. My profile depth up until that step over there. Technology, let's start off with a rough cut only. We'll leave over 0.3 millimeters, and we'll go to our clear offset. Now, clear offset is exactly how much do I want to, first of all, what's my clear offset itself? My first pass, or if I'm not sure what the distance here is, I know it's 20, but if I'm not sure, I can always click on offset and then click on the edge over here, and it'll automatically give me what that offset is. I'll just change it to 15 because the first one I don't want outside the part, and I want to step over every 5 millimeters. And I'm going to keep it working one way. I can work one way or zigzag, going back and forth. Let's keep it working one way, and I'll do a link with an arc. I'll extend it past that point a bit, say by 2 millimeters. And I'll do the same for my lead out as well. First of all, let's take a look at what's actually happening over here. If we take a look at the simulation, I'll do this in Solid Verify. You'll see that the tool goes down, clears off the first step, but now look what happens. It's going down and continuing in this area over here until it gets to the bottom. When it does that, only then does it go over to its next step, as shown over here. Now, there are some people that would say, you know, what I'd rather do is I'd rather first work across and then go down to my next step. Well, we can do that as well. If I go back to my technology, we have complete Z level. If I click on complete Z level, it'll actually complete the Z level before it goes down to its next Z level. Let's take a look at what happens over here now. And as you can see, the tool is going down and it's clearing now the next step over and the next one and the next one. But look what happens now. It jumps to the other side because complete Z level is complete Z level. Now, what if I wanted to stay on this side just before it goes to that chain, complete this chain over here? So what I can do is I say sort by chains. When I have complete Z level, I can say, okay, but sort my chains as well. Now let's take a look what happens. And as you can see, it's going to finish the first step over here. And then when it finishes this, it's going to stay on that side and go down to the next level. Okay, now it's going to do this for the rest of the part, as shown over here. Then when it finishes this, then it goes over to the other side over here. Now, next, we still have to do a finish. So I'll do save and copy. I'll go into my technology. I'm going to use the exact same tool, but this time I'm going to use finish without doing a rough cut. Okay. Note, in my offsets, my wall offsets is left open. And it's put at 0.3 millimeters. That's the amount I left over that time. And we have our step down. I'm going to have a step down at every 5 millimeters. Sorry, 5 millimeters. There we go. Now, the reason why I have a step down is as follows. First of all, look what's going to happen. Since I'm doing only the finish cut, what's going to happen, it's going to go straight to the floor and finish off the floor. Okay? Now, what I forgot to do with my previous operation, I'm going to go back and do it so we can see it a lot better, is in my technology, in my floor finish, I didn't leave a floor finish, I'll do 0.15. Run my simulation. And it left over excess amount on the floor itself as well. Going back into this operation here. Now let's run my simulation again. Actually, let me run both of them just to make sure I got it right. Correct. Okay. We have our first operation as I showed you before. Now, when I do the finish operation, what you'll notice is follows. It'll go down. It'll work exactly just on the floor itself. You can see it. I'll zoom in. It'll work exactly on the floor. Up until the wall, without touching the wall. Now, when it gets to the wall, it's going to go up, and now it's going to clean the floor with the wall itself every 5 millimeters. That's what the 5 millimeters is for the step down. Where the finish cut does 5 millimeters step down. Okay, now I'm going to stay on this part, and I'm going to deal with, I'm going to actually open up a new part, and now we're going to talk about choosing open pockets. The different options, the different ways we can choose, different ways we can choose open pockets. That's not the part I wanted. We'll see that in a few moments. Open pocket. Okay. Now, I'm going to actually do some of the operations over here, and I'm going to start off by clearing out this area over here using an open pocket. Now, this is a very obvious open pocket where it's open on one side over here. So I'll start my pocket operation. I'll go from this edge over here, that edge over here. Now, remember the rule of an open pocket, of any pocket, is that a pocket must be completely closed. The chain must be completely closed. Sorry, let me choose my geometry. 1, 2, 3, 4, 5. Okay, now, normally the way people will close this chain is to click another point to the other side, and then go back into the chain and choose, okay, open it from this point to this point. What I'm going to do here is a little different. I'm going to have these 3 sides done over here. I'm just going to accept it the way it is right now. Note, the moment I accept it, it's going to ask me, do I want to close it with a line? And if I do close it with a line, do I want to have it as open? Mark that line as open. I'm going to say yes. And what happens is we have a closed chain where this side shows that this is an open wall. I'll just accept it. We have our tools. I'll use my 16 millimeter end mill over here. We have our levels, my upper level being over here, my lower level being at the very bottom over here. And we have our technology. I'll just put it at use profile strategy, approach from outside. And as you can see, it'll work exactly from the outside. And this was one way of marking an open edge. Okay, now let's go to a different way of marking open edges. I want to do actually this surface over here now, where the entire outside is an open edge, and the inside obviously is closed. So we'll start another pocket operation. This time when I go to choose my geometry, I'll use the option of multi-chains. When I use the option of multi-chains, we'll go into faces. Now what's nice about using this option over here of faces in this case is when I pick my external loop, I can say, okay, mark that external loop automatically as open. So the moment I click on this surface over here, that outside chain is automatically open already. I don't have to mark it as an open chain. Again, we have our tool. Again, we have our levels. Sorry, my upper level is fine. My pocket depth up until this surface over here. Technology, open pocket, use profile, save calculate. You know it's working from the outside. Up until exactly where I wanted it to work. Okay, now let's do one more pocket operation over here. And this pocket operation this time is I'm going to work on this surface over here. Now, my chain obviously is going to be this area around in here itself, okay? However, this side over here is open and this side over here is open. Notice we have 8 sides, as you see, of this is actually open, where 2 sides are actually closed. So what I'm going to do is choose my operation of a pocket. I'll create a chain geometry simply just by clicking over there and do auto constant Z. And what I'm going to do, instead of marking each one of these as an open chain, I'm going to mark the entire chain as open. Mark chain is open. The entire chain is open. Now when I right click on this again and go to mark open edges, I'm going to choose the option over here of wall. And now I have, instead of picking 8 open walls, I'll just click walls over here. This is open, this is closed, sorry, and this is closed. So I'm just picking now this time instead the closed areas instead of the opened areas. Made it a lot easier to pick up that time. Tools, again, I'll use the exact same end mill. My levels, pocket depth up until that surface over there. We have our technology, again, open pockets. I like to work this way. Save and calculate, simulate. And as you can see, it clears out everything in the middle, where these areas are considered open. Okay. Now, next I'd like to show you a different operation for T-slots. So I'm going to leave this part because I have actually on the side of this part a T-slot operation that I need to do. Again, excuse my voice, I'm a little hoarse today. We'll work in this area over here. So for that, we're going to use the option of T-slot. We'll go into T-slot. My geometry in this case will be this edge over here. My tool will be the slot mill as shown over here. Now the slot mill has a diameter of 24 millimeters, where the cutting length is 4 millimeters altogether, with a 12 millimeter diameter. So I have no problem with that. Now my levels, my upper level is going to start from this point over here up until this floor over here, going down a total of 15 millimeters. Now let's go into our technology. I'm going to do only a rough cut. Now when we do the rough cut, first of all, we have our cutting depth overlap. If I have a 4 millimeter cutting length, I want to have a little bit of an overlap as it's going down on the cuts itself. So I'm just going to tell it, give it a 1 millimeter overlap between each cut. Now, this part, people always miss this for some reason. So I'm going to explain this part again. We have cut from. Do I want to start from the top towards the bottom? Do I want to start from the bottom towards the top? But what a lot of people like to do is actually use either middle to top or middle to bottom or middle to top. What that does is actually first goes into the middle of the part, goes down, and then clears off whatever's left up on top. Of course, now let's have a wall offset of 0.3 millimeters. And you know what? I'll have a ceiling offset of 0.15 and the same thing with a floor offset of 0.15 as well. Okay, my links. Let me have a link of tangent. Let's say we have a 24 millimeter diameter, so let's give it 12. So let's give it 14 millimeters. And the same thing for my lead out. Save and calculate. Let's take a look what happens. It's actually going down. Let's take a look from the side view as shown over here. It's going down to the exact middle over here. Going across. Going back up as it cleared off the side. Now when it comes back onto this side, it's going down. Let me flip it over again to the other side. And you can see when it goes down, we have a little bit of an overlap over here. It'll completely clear this area over here. Now let's take a look at the whole part over here. And you can see towards the bottom, now it's clearing the top, leaving the excess material exactly the way I wanted it to. Now I'd like to do a finish operation. So I'll do a save and copy. And when I go into my technology, I'm going to get rid of I'm going to put on my finish operation, but get rid of my rough. Now, I can go and finish more of my ceiling, wall, floors in one shot. Or if I want, I can say, you know what? I want to do my ceiling and floor separately. I just want to clear off my wall. Note when I do this, this is what's left open. Offsets wall for ceiling and floor. If I were to have ceiling without wall, then this is open. And as you can see, you can toggle around. You can see toggle around, and you can see exactly what happens when I say I don't want a specific one. Okay, so like I said, I want to finish off the wall. And this time I also have here the same options of top to bottom. I'm just going to go straight from top to bottom for now. Save and calculate. Run my simulation. Actually, let me run both my simulations. And I'll do it using... No, I'll use it... Let me just do this simulation here itself. And I'll use Solid Verify. You see the tool will go down. It'll cut across. Now note, it did not touch the top over here. It did not touch the bottom. That's because I told it, I want you to leave excess material. Don't do a finish there. Now, if I were to do finish here and here as well, in that case, it'll actually finish everything. As you can see, it finishes now the floor and the ceiling as well. Okay. Next, I'd like to talk about Contour 3D. I'm going to load a part. And what Contour 3D does is it takes a regular chain geometry and actually follows that chain. Even if that chain goes off on an angle towards in the depth itself, it'll follow that chain. In other words, the depth is controlled by the shape of the chain itself. So just to show you exactly how this works, I'm going to hide the part itself, and I have a sketch here instead, with the exact edges over there, just to show you that it doesn't even look at the model itself. It has no idea what the model is itself. It just looks at the chain. I'll use the operation, as I said, Contour 3D. choose my geometry. It's actually going in the opposite direction. And we'll do, sorry, not automatic open chain over here. There we go, the entire chain. Let's bring back the part so we can see exactly what we're going to be doing. And what I'd like to do actually in this particular part is put a chamfer on this edge. It's a very good tool for putting chamfers on edges such as these over here. So I'm going to use what we call a chamfer tool. I have here a chamfer tool. And in my levels, let's skip levels for a moment. Let's go to my technology. First of all, my technology, I want to work off to the left side. Okay, and I want to do a finish cut. But as I said, I want to do it as a chamfer. So we have here the option of chamfer. Now when I use chamfer, I just go into the chamfer field and say my cutting diameter is going to be, what's the cutting diameter I want to use? I'm going to use my 1 millimeter cutting diameter of that tool. Now if I go to my levels, we have here the depth. This is the actual depth that I want my chamfer to be. Let's say I want my chamfer to be 0.5 millimeters. No problem. That's the depth of my chamfer will be around the part. Let me just go into my links. I'm going to approach with an arc and retract with an arc as well. Run my simulation, and I'll do this using Solid Verify. You'll see that the tool will go down. Let me actually zoom in to this area itself. And you can see the chamfer that's being put on the part itself all the way around. Actually, let me do it now so you can see the entire motion of the entire tool. You'll see that the tool goes down, follows the exact shape of that edge itself. Okay? Now, one more part I'd like to show you, and this is actually showing you pocket and drill recognition. And yes, now, I want you to note what I have on this part. In this part itself, I have several different pockets. I also have here steps on the side, and I have here holes as well, of different diameters and at different levels as well. Now, note also in 3 of these pockets, I have radiuses at the very bottom of each pocket itself, where this radius over here is a 1 millimeter radius, this is a 2 millimeter radius, and this one is even larger, a 3 millimeter radius. Excuse me, a 3 millimeter radius. Now also note, we have here a pocket with an open edge, and also inside this pocket here, we also have one with open edges as well. So we'll start our operation of recognition called pocket recognition. When I go to define my pocket recognition, first of all note, I don't want to take any of these holes here as pockets. We have a, excuse me, we have a filter here for diameters. And say, okay, any diameter that's smaller, say, than this, which is 7 millimeters, don't take it. You know what? I'll just make it at 10 millimeters. Now, when I touch the part, click on the part itself, it diagnoses the part and finds me every single face that's on the part here, on the part itself. And if it's a through chain, such as this one, it'll find the very bottom of that chain as well. Excellent. Next, I'm going to use a tool, and I'm using a sharp edge tool of 12 millimeters. Not a radius edge, but a sharp edge. Now, let me go back to my geometry, because there's one thing I wanted to point out here to you. If we go to our geometry, we have modify. Now, note, right now it's showing us everything that's taking. All the surfaces, all the edges over here, okay? It even shows me the top surface. Now, the top surface, I don't need. Now, I'm not going to start searching through all of these, which one is the top surface. All I have to do is click on exclude top face. This top face will automatically then be excluded. Now, note there's one area over here that I'm going to get back to in a moment. Something called fillets, number of steps. What's going to happen over here is because there's a fillet over here, it recognizes that there's a fillet. And it will not go down all the way to the bottom over there. Instead, it will make a step over to make sure we have material left over for a fillet, for a bullnose tool with the proper fillets. Okay, let's accept this just the way it is right now. We have our tools, levels. Notice we don't have anything to do over there. I'm just going to leave it exactly everything the way it is. Run my simulation. Actually, I'll run it using Solid Verify. Note it cleans out each one of the pockets exactly the way it's supposed to, all the steps. And note, every single one of the places where we had a radius, we have a step here, leaving material over for the radius itself. Same thing here, and same thing here. However, if I'm looking at this closer, you'll note that this was a 3 millimeter radius over here, and this kind of material left over for 3 millimeter radius is a lot of material. And the same thing over here with the 2 millimeter radius. I like to actually break it up into smaller steps. The way we do this is as follows. If we go back into geometry, we have the option of modify. And in modify, we have, as I showed you before, we have fillets and number of steps. Now, if I click on number of steps, first of all, it recognizes the fact that my biggest radius is 3 millimeters. And as it done it up until now, it did all of them, everything that's between 0 and 3, it did it with a 1 millimeter, one step. Now, I can break this down into more steps just by opening up more fields. This is another field. Now it's broken down from 0 to 1.5 and from 1.5 to 3. But I want to go even further down. Okay, I can go further down. I can go up to 4 times. So I can have here up to 4 steps. So anything between 0 and 1.5 is 1, 1.5 and 2.25 is 2, and 2.625 up until 3 is 4 steps over here. Let's take a look at the results. Run our simulation. And note now we have this down here at 4 separate steps. 1, 2, 3, 4 separate steps. Here we have it at 2 steps, and the 1 millimeter, we have it at 1 step. Of course, I could have broken it down. I could have written down as many steps as I wanted over there. So I can get this actually pretty smooth down until it's actually what I would like to have for a fillet, for a bullnose tool to finish that off. Okay, now let's deal with these holes over here. As I said, these holes are of different diameters. We have 2 separate types of diameters, and they're also on different levels. We'll use the option of recognition of drill recognition. What I'm going to do is say, okay, you know what? Find me all the holes. I'll click on it. Note that it found me all the holes, including this hole over here. Okay? Now, I don't need that hole. So let's go back over here. We have hole diameter. Let's actually limit it between 2 holes, 2 diameters. I'm going to go, my first diameter is this one over here. And my second one is this one over there. Sorry, went out by accident. My first one, like I said, is over here. Second one over here. Find holes. This time it did not choose that hole at all. Okay, now what I'd like to do is use a spot drill and make a spot drill for each one of these holes, even leaving a little bit of a chamfer. So I'll use spot drill. And when I go to my levels, I'm going to go to my depth edit. Now in my depth edit, I'll do the following. First of all, we'll have an option over here called auto chamfer spot drill. Okay, and I'm going to do it for all of them. Apply. So now all of it's recognized for the spot drill. Now what I'm also going to do is I'm going to say, what do I want to have as my chamfer depth? Let's have it at 0.3 millimeter chamfer depth for all of them. click on apply. Let's see what happens in my simulation. You'll see that you're getting a spot drill at each different level, and each hole is getting the proper depth of the spot drill according to exactly what it needs. Now, let's do save and copy. Now I'd like to finish off these holes over here first, my smaller holes. So I'm going to choose a new geometry. New. We use hole diameter over here. And the hole diameter that I want, I'm going to highlight this area and just click on the small hole. Note they both turn into 5. Find holes. That's it. Note broken up to 3 groups, goes on 3 different levels. My tool, this time will be a 5mm drill. Of course, my level is not even going into it this time. It's a blind hole, so I have no problem with that. My technology, we have drill cycles if we want. Let's just run our simulation. And as you can see, it's drilling out all of those holes, everyone to their respective depth, as shown over here. Everyone to its each exact depth that need to go. We're still going to do one more operation. We'll do save and copy because I still have to do the larger holes. This time I'll choose hole diameters, and this time I'll click over here and click on the larger hole itself. Find holes. Okay, now these holes are through holes. When I pick my tool, first of all, I'll pick my 7mm and drill, and in my levels, when I go into depth edit, we'll use the option of full diameter instead of cutter tip. I'll put this for all of them and apply. So it took all the groups and made them as through drills. Run my simulation. As you can see, it's running through every single one of those drills all the way to the bottom, and you can also see, as I zoom in, you can see the chamfer that was left over from the previous operation. So just to sum up what we did over here, we went over the options that we have in Toolbox that can help us out. We saw the different operation. We saw how one way in face can help us out on specific faces, not just the entire part. We saw on profile operation how we use clear offset correctly. We saw also how to create different ways of creating open chains in pockets, for open pockets, and how to use Contour 3D for chamfers, using T-slots, and as I showed you over here, pocket and drill recognition. Okay, thank you very much for joining the webinar, and this webinar will be posted on our website by tomorrow after I finish rendering the recording of it itself. So everyone take care, have a great weekend. Bye-bye.